Hello, this video is a quick workflow walkthrough of the pyNITA application. So this doesn't get into the details too much. For that, you can refer to several other forthcoming videos and the larger instruction document. So this assumes that you've gone to the pyNITA GUI GitHub page and you've found the README area, and you've probably followed this binary distribution workflow to get a simple double-click executable, along with grabbing a demo data set if you've wanted to. At this point, I will double click on my executable that I've got, and this is going to pop up the application. So we'll go through the four main steps here. So the first thing is just setting working directory and adding your user configuration file. So my working directory is wherever I put my demo data set for right now, which for me is right there. And I'm going to submit that, grab my user configuration file, which is going to generally be right inside there by default. And this is going to add all the different initial parameters, many of which are, a reasonable starting point. And then you can notice that if I hover my mouse over any of these parameters, it will give a little bit of information with more detail being in the main instructions. So for now, I'm just going to leave these the way they are. Step 2 is where you can look at a few points that presumably you know kind of well, like, hey, I know that there was a disturbance at this point in 2015. And this lets you do a better job of setting your parameters. So this is an oil palm area in Indonesia. So I'm going to bring in my oil palm sample points, submit that. And here's where I can enter in some IDs of points to look at. If I don't remember what those are, I can show the point metadata and see descriptions and the actual object IDs that I need to put in. So for now, I'm just going to put in a range of 1 to 9 just to get a sense of what's going on. We'll visualize these. They've popped up on my other monitor. Expand this out. And so this is showing you for 9 different pixels over the range of this data set from 1995 onward, what the current set of parameters leads to in terms of a fit. And so you can see, for example, in this first window, it picks up this disturbance nicely, starting in maybe 2012, but not sure exactly. But the main nadir of the disturbance is in 2015, which corresponds with a lot of this oil palm development. And you can see that maybe some of these pixel histories are not perfect. For example, in the bottom left here, it looks like there's a disturbance that should be picked up. And so this gives you some basis to think about what parameters to adjust. And again, other videos would go into that a bit more. For now, we're going to say, okay, good enough for right now, and move on. Down here, you're also able to hand draw some of those trajectories in order to tell NITA what sort of parameters to find on its own to match up with your hand drawing. So it's sort of an automated optimization procedure that I'm not going to show right now because frequently you will not use it. Moving on to the actual production side of things, where we're going to implement this algorithm on your images. We just need to bring in the images. So in this case, it's a NBR, normalized burn ratio, vegetation index, but you could also use NDVI at the moment, and we could expand that out in the future. NBR along with a CSV of the dates of each of those images in this image stack. And this assumes that you've gotten these images through our Google Earth Engine workflow detailed elsewhere. Submit that. Now this is kind of nice because if you have large data sets, you may not want to just run the code immediately on your entire data set. So this one happens to be small, But nonetheless, I'll still show this subsetting routine where it brings up your least cloudy image in your whole stack, and then you can just simply draw out a box on an area of interest, click done, and now you can just run this NITA code with as many of your processors as you want or have available. We'll do 8 for right now, and it's just going to run on that subset. You're seeing the progress here. It's going to be pretty quick. Actually computing those trajectories. So now we see that the image metrics are created, and we move to step 4, which is actually looking at the metric images and saving them off. So with a subset, you can't save anything. So this is just for visualization right now. So a good one for this particular landscape to look at is disturbance date. Submit that. And this is not going to look too exciting because it's a tiny subset of an area that you may not be familiar with, but nonetheless, it shows that on the right side, there's disturbance, and this is the border of the oil palm plantation. And on the left side, it's no disturbance because it's stable forest. And so I can see like, maybe I thought there was disturbance over here. And I can click on a pixel there, and I can see, there should have been a disturbance. Interesting. So what that means is somehow my parameter set is not declaring that like an adequate loss of vegetation index to be a disturbance. So this gives me some insight that I may need to make some changes still. So if we compare that to something where there actually is a recorded disturbance, you can sort of see what the difference is. This one is a much deeper accounting for the disturbance, which may still be the same process as the other pixel. We compare that to something that exhibits more stability, albeit with lots of atmospheric noise. This is going to be something that's a stable primary forest pixel or something like that. So of course I can do all of these different images. One more that I like to show is just linear error, which is just a simple calculation of how much does your pixel's trajectory deviate from a simple linear fit. And it basically shows two things: how noisy the pixel is and how much it's a nonlinear process that's happening. So it's frequently a good starting place to see where pyNITA should really add some value as far as characterizing the pixel history. So of course I'd go back and run the full thing again so I can save, but that is it for now.